In this video, we're going to be learning about geometric proofs, particularly ones with segments and angles. So in geometric proofs, we can use properties of equality, properties of congruence, which we'll look at in a minute, or geometry definitions to help us complete the proof. The properties of equality that we've learned about are addition, subtraction, multiplication, division, substitution, and the distributive property. Since we're calling these properties of equality, we should take note that these apply to equations, meaning there has to be an equal sign. Whereas in some proofs, you'll see the congruent symbol, and that's when you should use a property of congruence. Congruent angles have equal measures, and congruent segments have equal measure. And below are some properties and postulates we are going to use in these proofs. So first we have three properties of congruence. So the reflexive property of congruence, take note that they have the congruent symbol in here. So the reflexive property says anything is congruent to itself. So AB is congruent to AB, or angle A is congruent to angle A. The symmetric property of congruence says that if AB is congruent to CD, then we can reverse that and say CD is congruent to AB. Finally, the transitive property of congruence says that if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Basically, if these two are congruent and these two are congruent, these missing pieces, AB and EF, must also be congruent. Okay, then we also have two postulates. One is called the angle addition postulate, and one is called the segment addition postulate. So let's look at the angle addition. If point D is in the interior of angle ABC, and B is the common vertex of angle ABD and angle DBC, then so let's think about how we have this written here. So if D is in the interior of the angle, we see that here. It is inside angle ABC. And we see that these two angles, ABD and DBC, share point B as their vertex. Here's how we're going to write our angle addition postulate. So we could say that the measure of angle ABD plus the measure of angle DBC, when we add them together, we would get the measure of angle ABC. Basically, if we add the two smaller pieces together, we'll get the measure of the whole thing. If we were looking at that in terms of congruence, we could say that angle ABD plus angle DBC is congruent to angle ABC. Now, the segment addition postulate is very similar, except we're dealing with line segments. So if points A, B, and C are collinear, that means they share the same line, and B is between A and C, then AB plus BC is equal to AC. Or if we're looking at this in terms of congruence, we could say that segment AB plus segment BC is equal to segment AC. Congruent to segment AC. Okay, so those are our five properties and postulates that we'll be using in some proofs today. All right, we're going to take a look at two examples. One has to do with angles and one has to do with segments. All right, number one says to complete the reasons in the proof. So we know that angles ABD and DBE are complementary. Okay, I'm just going to mark on my picture that would mean they form a right angle. We also know that, and that's, I should also note there, they form a right angle since they are adjacent angles. They share the same vertex. Complementary would mean they add up to 90. ABD and EBC have a sum of 90. So this angle here and this angle here have a sum of 90 degrees. We want to prove that angle DBE and angle EBC are congruent to one another. All right, let's start with our proof. So statement one says angle ABD and angle DBE are complementary, and that the measure of angle ABD and the measure of angle ABC is 90. Well, that was just our given information, so I'm just going to write given in there. All right, number 2. The measure of angle ABD and the measure of angle DBE is equal to 90. Well, we know that's true because those two angles are complementary. So I'm going to describe that reason as if two angles are complementary, then they add up to 90 degrees. All right, line 3 looks a little bit different here. So sometimes this could be a part of a proof where people get stuck, but let's take a look at it. It says the measure of angle ABD plus the measure of angle DBE. So far it starts to look like line 2 is equal to the measure of angle ABD plus the measure of angle EBC. Basically what's happening here is we're using this information from the given. So we're taking that piece, and since we know that it's equal to 90, what we're doing is we're basically plugging it in there instead of the 90. And when you're plugging something in, that's called the substitution property. Okay, for number 4, compare it to the previous line. Notice that the angle ABDs, the measure of angle ABDs, have gone away. So we've really subtracted that from both sides. So imagine here, I'll write it in here so you can see. Imagine we subtracted that from both sides. Those pieces would go away. So this is the subtraction property of equality. And finally, we're asked to prove that these angles are congruent. So we already know they're equal. So we're going to write here that angles with equal measures are congruent. And now we have completed number 1. Let's take a look at a segment proof. So we are given that M is the midpoint of AB. I'm going to fill in reason 1 right now as the given. And we're asked to prove that when we double AM, that we would get AB. All right, so let's go piece by piece and see if we could fill in these reasons here. So statement 2 says that AM is equal to MB. Well, think about how this expands upon what we know in statement 1 in the givens. If M is the midpoint, we know a midpoint splits a line segment into 2 equal parts. So I'm going to write that basically as my reason 2, that a midpoint, it's like our definition of a midpoint, splits a segment into 2 equal parts. All right, now let's compare lines 2 and 3. Always look at the previous line as a hint. Now you can see that AM has been added to both sides. So imagine me adding AM to both sides. That's where we're getting these extra AMs from in line 3. So if I'm adding, that's the addition property of equality. In line 4, you could see that we just combined like terms here, right? AM plus AM would be 2AM. So I'm just going to write here for reason 4 that we simplified, or you could write combine like terms. Okay, number 5. AM plus MB is equal to AB. So if I look at the previous line, I might not initially see how that relates. So I'm going to think about our properties and postulates that we've talked about previously, and I'm going to look at the picture. I can see on the picture that AM plus MB is going to give me AB, and that's because of the segment addition postulate. All right, finally for line 6, our proof statement, we wanted to prove that 2AM is equal to AB. So take a look here at lines 4 and 5. So both of them have AM plus MB. That must mean these remaining pieces are equal. So 2AM and AB are equal, and that is by the substitution property. So as a recap, as this video ends here, when you are doing a line segment or an angle proof, you want to think about definitions that you've learned in geometry, different properties and postulates, and you want to think about also sometimes adding in a simplifying step like we did here in line 4.